Question number 3. It's giving you some data here regarding partial vapor pressures of HCl that's in liquid germanium tetrachloride. Okay. Notice these mole fractions are really, really small. So what that leads us to think about is, and as we recall, Rolt's law really talked about a perfect sort of straight line relationship between two things, if it was ideal. And we've talked before about how the real data might, do something kind of like this. So we did say that if this happened to be A, just for example, Henry's law was more interested in when you had a small amount, a very small amount of B. And right here, there was a straight line relationship right there. And this would have been Henry's law constant. So that's kind of the idea. And this does make mention, calculate Henry's law constant. So anytime I see Henry's law, I'm thinking the mole fraction of something has to be quite small inside of something else. So long story short, what this is telling me to do, Henry's law says there's a straight line relationship when there's low mole fraction. So basically graph this and get a straight line relation. That's what you're doing. So folks, this data would ask you to, on a graph of P versus, I want to make sure we're okay with this. I want to make sure I piece this together okay. Yeah. So the relation would be, in this case, if this was mole fraction of HCl, and you're sticking to very small numbers, 0.05, whatever. So basically, you're going to plot those 3 data points and straight line it. And when the, let's think about it, it's the slope. So that's how this is going to work. The partial pressure of HCl will equal the mole fraction of HCl times Henry's constant of HCl. So when you plot these 3 points, the slope, this y-intercept is also k, but the slope is also equal to that Henry's constant. So in other words, plot your 3 data points, and you're going to get something that looks like y equals mx plus b. The b is going to be quite small, probably. But anyway, you want the slope. The slope will be Henry's law constant. So in a nutshell, use Excel. Graph those 3 points, mole fraction versus the pressures that you're seeing. And then the slope of that graph will give you Henry's constant. And it's looking to me like, yeah, this is in kilopascals, right? So that's in kilopascals. So that slope is, let's just say it's somewhere between 5 and 7,000 kPa. Somewhere in that range is what you're looking for. So that's number 3.